Have you ever stared at a bottle of salad dressing and wondered, why does this stuff always separate? Or, on the flip side, how does your face cream stay so perfectly blended? Well, there's actually a secret science happening right in front of us, a kind of everyday magic. And today, we're diving into that unmixable mix. You know, it's one of the first things we learn. Oil and water just do not mix. It's a fundamental rule of nature, right? Their molecules are just wired differently. Water molecules are polar. Think of them like tiny little magnets, always clinging to each other. Oil molecules, they're nonpolar. They just don't have that same attraction. And yet, just look around your house. Your kitchen, your bathroom, they're filled with products that completely defy this rule. So what gives? How is it done? Well, the solution is pretty brilliant.
The secret is a powerful little concept called an emulsion. The best way to think of it is as a scientific peacemaker. It's like a special agent that steps in and convinces these two liquids, which normally can't stand each other, to just get along and form a nice, stable team.
So yeah, in simple terms, an emulsion is just a stable blend of things that shouldn't be able to blend. But don't let that simplicity fool you. This one idea is a huge cornerstone of chemistry. And understanding it? Well, that's the key to everything from making our food taste better to delivering life-saving drugs. It's a really big deal.
Okay, so how do you actually make one of these? Well, you can think of it kind of like baking a cake. You got to have the right ingredients, you need the right tools, and most importantly,
you have to follow the recipe.
And one of the most classic, old-school recipes in the world of pharmacy is actually pretty simple. It's a time-tested formula for creating these things by hand, and it all boils down to one very specific, very memorable ratio. Get this, it's 4-2-1. That's 4 parts oil, 2 parts water, and 1 super important part of a special gum. Now, that gum, that's the secret sauce. It's the emulsifier. Its molecules are kind of two-faced in a good way. One end absolutely loves oil, and the other end loves water. This lets it act like a tiny bridge, physically holding the oil and water together. It's the whole basis for what's called the dry gum method.
And the process itself is absolutely crucial. First, you coat the gum completely with the oil. Then comes the big moment. You dump in all the water at once, and then you just mix like crazy. This super fast, energetic mixing literally shatters the oil into microscopic droplets. This allows those gum molecules to just swarm in, wrap around each tiny droplet, and form a protective shield that stops them from clumping back together.
Now, of course, the tools we use have evolved a lot. What a pharmacist used to do with a little hand-powered crank is now done with these giant, high-tech mechanical mixers for making stuff on a huge scale. But the core idea is exactly the same. You need intense, forceful mixing. The technology has just gotten way, way bigger. But here's the thing. That perfect, smooth mix, it's not going to last forever. See, every single emulsion is in a constant fight against physics. It's always trying to revert back to its natural state, which is to separate. And in the end, physics almost always wins. So what does it look like when it all falls apart?
The truth is, all emulsions are basically unstable at their core. They have a shelf life, and they don't just suddenly fail. Nope. Their breakdown is a slow, gradual process that happens in 3 very distinct stages.
The first sign of trouble is something called flocculation. This is where the individual oil droplets start to form little cliques. They start gathering in these loose clumps. They're still individual droplets, mind you, but they're not spread out evenly anymore. You could say they're starting to team up.
Then you get to stage 2, creaming. Now, because oil is lighter than water, those little clumps start to float to the top, and they form that distinct layer you see. This is exactly what's happening with your salad dressing. But here's the good news. At this point, you can still save it. A really good hard shake can break those clumps up and buy you some more time.
But if you leave it alone, creaming leads to the final catastrophic stage, breaking. This is where the droplets inside the clumps actually start to merge together. They coalesce, forming bigger and bigger blobs of oil until, finally, you're left with 2 totally separate layers. The emulsion is officially toast.
And once an emulsion hits this point, well, that's it. There's no coming back. That protective barrier around the droplets is gone for good. You can shake it all day long, it's not going to fix it. The mixture is, as they say, cracked or broken.
So, now that we've seen how they're made and how they die, let's get to the fun part. Let's look at where these amazing mixtures actually show up in our lives. And I promise you, once you start looking, you'll see them absolutely everywhere.
Okay, check this out. A perfect example right from the pharmacy, a mineral oil emulsion. And if you look closely at that recipe, yep, there it is, our good old 4-to-2-to-1 ratio.
By turning it into an emulsion, plain mineral oil becomes a much more palatable medicine, often used as a gentle laxative.
And it's not just stuff you take orally. That soothing pink calamine lotion for bug bites, that's an emulsion. Your medicated shampoo? Yep, emulsion. The liniment you rub on sore muscles? You guessed it. They are literally hiding in plain sight all over your medicine cabinet.
But the story doesn't stop with lotions and liniments. Oh no. The basic principle behind the emulsion is now being used to create some of the most cutting-edge medical technologies on the planet. I want you to meet the liposome. It's basically a microscopic hollow ball, a kind of nano-emulsion. And what's so amazing about it is that scientists can pack medicine inside its core. Think of it like a tiny, targeted delivery drone that can carry a drug directly to specific cells in your body. It's completely revolutionizing how we deliver medicine.
So the next time you pick up a bottle of lotion or shake up some vinaigrette, you'll know the secret science that's going on inside. This unmixable mix. It really is everywhere, hiding right under our noses. So now that you're in on the secret, the only question is, what emulsion will you spot next?